super interesting guest. I ran across this company reading a market research report, to be honest, and I reached out, and their CEO, who you're about to meet, was kind enough to respond, and we had a nice chat the other day. And hopefully, as we were just saying before I hit record, hopefully he won't have any naked children running across the screen, or dogs, or anything else. But anyway, why don't you introduce yourself and tell us what you do?
Yeah, my name is Shaun Cooley. I'm the founder and CEO of Mapped. Mapped is a data infrastructure for IoT company focused on commercial and industrial IoT.
What the hell does that mean? I mean, literally, you said every buzzword, but machine learning and AI.
Yeah, there was no digital twins mentioned in there.
No.
Yeah. So look, I should give a little background on myself. So I spent 18 years at Symantec as a distinguished engineer in the Norton Group, and then 6 years at Cisco as vice president CTO for the Internet of Things group at Cisco. I think while I was at Cisco, I would take any customer I could up on an offer to come visit their site. So didn't matter if it was a factory floor, an oil rig, down in a mine, on the roof of a building. If there was an offer there, I'd be on the next plane to go do it. And I think one of the things that became very, very clear to me was that customers struggle to get data out of their existing automation environments. These environments are largely bespoke. They're very complex. The information is siloed. Point names are all unique and put in by whoever the system integrator was that came through there at whatever time with whatever bag of tools they had in that era. The environments are great. They operate as needed, but when you try to at scale get information out of these environments, it is a very manual process today. The application enablement platforms that exist out in the market require you to bring your own data model, bring your own ontology, bring your own gateways and protocol drivers and connectivity, and reverse engineer all the pieces that exist inside of your environment. And if you do that in one factory, you can get an application up and running in 6 months or so. And then you go to your factory that's across the street or on the other side of the country, and it turns out you got to do it from scratch again. And so the observation was just that this is pretty broken today. And we needed a better way to do that. And so what we focus on is finding ways to automate the discovery, extraction, and normalization of data into a standardized ontology. Lots of more buzzwords in there that I just threw in, but
if you say taxonomy, I'm going to cut off this thing immediately.
There's no taxonomy, just ontology, right?
Yes,
But yeah, the end goal is that developers should be able to focus on just a single API where the underlying complexities have been abstracted away from them, and they can really focus on the data and the sort of insights that they're looking for through the connections and the data that exists, and not having to worry about, is this OPC or S7 or BACnet or mod or Profi? Did the manufacturer do it to spec, or did they do a bunch of custom things? What fields or registers do I care about? At the end of the day, you just want to know how much energy is being used, what's the temperature, is it vibrating, like what's happening in my environment at the moment.
So does incorporating your offering break the security model? Let me now give context.
Yeah.
Initially, and I come from the telco background, as we've discussed, I was at Vodafone on the global IoT side, and we would intentionally set up silos, for better or worse, that connected objects that were on a cellular network primarily, and private APN, VPN tunnels. It was beyond security through obscurity. Like you couldn't see it. It's on a separate network segment. It was not on the public internet. And that was part of the security model. So if you're a medical device manufacturer, your cardiac monitors are not visible, are not discoverable, and that's intentional. It's by design. How does that fit with what you guys are trying to do?
Yeah. Well, I think, when you look at a lot of these environments, the security, somewhat by obscurity, but a lot more security by physical access has been the way that they've existed forever. If you can physically walk onto a factory floor, you can very likely plug into an engineering port and see everything. And so I think that over the last, 5 to 10 years, these customers have gotten a little more comfortable with the data moving up to the cloud to some extent. Many of them are already putting financial records in the cloud and other things that are probably more sensitive than the factory automation or building automation data. From a security standpoint, though, it's our view that the more vendors who are coming in and plugging in boxes into your physical environment, the bigger your attack surface is, the broader your attack surface is.
Sure.
And you very quickly lose the sort of insights into where your data is going, who has access to it, who maybe has remote access into those physical boxes that were plugged into your environment. And today's sort of analytics or predictive maintenance or FDD or OE or anything that you're trying to achieve, all of them tend to involve putting a physical box into your environment. And so our view on that is, rather than sort of dealing with just physical security, let's take the data and move it once through a single pipe into the cloud, where now you can put proper API level security and proper access level security on top of those APIs, and make it so that you can very clearly see who's accessing the data and how they're accessing the data, and you end up with one pipe leaving your environment rather than many pipes leaving your environment. We obviously put a lot of effort into making sure that pipe is as secure as possible. So we use mutual TLS. Our box does a secure boot. The firmware is signed. It's got a hardware enclave. We put no local open ports. There's no remote management capabilities on the box that we put in. It is really just meant to reach out to our cloud and start pushing data up. From a control standpoint, today we are read-only, and so there is no ability to push commands back into that environment. We obviously have plans to change that in the future, but it does, to your point, require a lot of security work to be done to make sure that that's done in a secure way.
So you get into sort of data provenance issues in a way.
Yep.
So if you look at a building, picking one example, I know it's on your website. Buildings have multiple systems in there, multiple ecosystems, if you will. The HVAC system, you have the elevator escalator system, which is probably a different system. Individual offices might have different, or whether they're offices or labs, might have different systems monitoring different things in there.
That's right.
And then there's probably other things that are owned by the municipality. Maybe they've got parking lot underneath, and you've got parking resources and metering around that. How does that all mix and match? What was the Ghostbusters movie where they said don't cross the streams?
Yeah.
So how do you prevent yourself from crossing the streams?
That's right. Yeah. So we, as data, we sort of view it as two pieces. One is data producers. The other half of it is data consumers, right? And so on the data production side, you have many different parties or entities that are contributing data to the graph that we produce up in the cloud. We do track provenance all the way along. So the final sort of vertices and edges that are in the graph are tagged with the originator of them, the producer of them. So when you want access to different parts of the system, you need to request access from the producer of the system, of that data. And so I think the building one is a good example. It is not just different systems inside of it that are largely run by different either system integrators or operators. Now you've got Kone and Otis that are putting their own controls on top of the elevators, and they're doing elevator as a service. So like the building never really deals with anything on that. I think beyond that, the building oftentimes runs building-wide systems, HVAC, fire safety, vertical lifts, if they didn't outsource it to somebody else, parking, a few other things. In a high-rise building, the tenant oftentimes runs their own lighting. They have to build it out as part of their own their build-out. They also run access controls, calendaring, conference room systems, Wi-Fi access points, all these other things that are producing data. And so you have a bit of a mix where the tenant has access to their own stuff, but wants access to the building data. And then similarly, the building may have access to their own, but want access to the tenant data. And so that sort of data exchange, that permissioning is built into the platform that we've built.
So give me a use case. Let's kind of look at that. So I can imagine all the don'ts. I don't want my security feed being made available to somebody that doesn't have permission for it. But what are some of the things that you enable? What are some of the things that are not enabled in your ontology, taxonomy?
So we use an ontology called brick schema.
Okay.
So if anybody's interested, you can go take a look at brickschema.org, which is our ontology. Our chief data scientist is one of the co-creators of it. They just released the version 1.2, so you can go dig as deep as you want into all the different constructs that exist inside of there. I think from an access standpoint, the way that we slice it right now is both by sort of owner, right? So the owner is always the one granting it, but then you can control based on the origin location. So was this produced on the 3rd floor or the 2nd floor or the 5th floor of a building? And then also the system type. So I can say that an application, for example, can access only the 3rd and 4th floor, only energy data. Or I can say that this application can access the whole building, just vertical lifts. And so you can really play with that to try to get pretty fine-grained access control, at least much more fine-grained than you can get through the existing protocols that these things are running on. I think from a use case example, some of the use cases that we see most broadly are energy optimization. I want to know where I'm spending money on energy, where the energy is going. I want to be able to correlate sort of energy and occupancy. When there are more people in the building, am I spending more, or does my building continue to waste a bunch of energy when it's completely empty? Especially given the last year, I think a lot of buildings have started to ask this question. Right. And then you start looking at things like predictive maintenance. I'm looking at certain pieces of equipment to further complicate the issues around buildings. Even in the case where HVAC is owned by the entire building, the tenant may be on the hook for individual components that are within the tenant space. So in a triple net lease, that tenant may have to pay attention to, is the VAV dying, or did a thermostat die? And do I need to replace it or repair it or fix it? And so the predictive maintenance solutions start coming in there as well. Space optimization is a big one. Mm-hmm. You see this in a lot of office buildings where they will they'll take 50 cubes and turn it into a big couch, like relaxation area. And then it turns out nobody uses it, so they turn it back into cubes. And so really understanding how the space is utilized is pretty important. It is one of the more expensive things, is what you're paying per square foot for that space. And then really the last big bucket is in safety and security. And I think, especially as people return to the office now and, in the coming months, there's a lot of questions around where are people congregating, how long are they staying in a single area? Is the area cleaned, after that, are conference rooms at capacity or beyond capacity? How much fresh air is getting exchanged from the outside into my environment? All these sorts of things. And so we see, most of these use cases involve multiple different parties worth of data and multiple different silos of data to come together.
So you're knitting together the silos. And again, you're making an assumption that if we all meet at the building, and these however many groups of stakeholders, if you will, the Kones, the Schneider Electrics, I don't have to name vendor names, but the HVAC guys, the elevator guys, the security surveillance guys, all these guys are you're meeting with them at one point, and you're offering differing levels of permissions based on some model that you've been describing. I know in the case of some of the equipment, as you've said, it's owned by, if it's an as a service model, Kone owns the elevators, owns the lifts. How are you able to kind of broker all of that?
Yeah, so we don't, I guess just to clarify on that, so we do not directly interface with all of those individual parties. We look at a couple of different angles. One is the building itself, so owner, operator of the building, depending on the sort of way that building is structured. then the tenants inside of the building. And so once they've agreed and our platform goes in, we do all the discovery and extraction through automated mechanisms. And so those automated mechanisms allow the sort of owner, operator, or tenant to plug the box in, find the things onboarded into our platform. We do view the sort of second parties, the vendors that serve the space, as making use of the data as well. So you can imagine, even a Johnson Controls or a Carrier that's, serving millions of buildings worldwide. Today, they have to send people in to get information out of these buildings.
That's right.
And they are very interested in finding ways to do this. And so a building that is pure Johnson Controls top to bottom, the newest versions of Metasys send them data. They've got data in the cloud for it. But they are then missing data for the Lutron or Crestron lighting system, for the elevator systems, for other pieces of the building. And all of those, are obviously related to each other, both physically and otherwise. And so, our goal is to convince the building to put the platform in, and then let the other vendors start making use of it as they find value in the APIs.
So that would be, Johnson Controls could say, let me look at all my buildings and see if I can determine, it's a predictive, maintenance query, if you will. When do all my whatevers break, or when will they break, or, when should I, what version of whatever is out there, and et cetera. So how are you crawling through and finding all of this stuff?
Yeah, so we use techniques that are very similar to what you'd see in an enterprise asset management application. So, mixing a little bit of the security background that I have with some of the IoT work. The things that we do is a mix of passive packet monitoring. So whether it's on a serial bus or on an IP network, we're essentially watching for packets moving across the network that are of one of the protocols that we know how to handle. In addition, we either do a scan of device IDs on a serial bus, or we do sort of a port scan, IP scan across a subnet on the IP side. And the goal of that is to find all of these devices that are speaking various protocols. On the IP side, if I find a device that supports, it answers on 47808, that's BACnet, right? Like I know that I can speak BACnet to it now. As we find those devices, we then extract operational data from it and metadata. So the metadata that we're looking for is sort of make, model, firmware. Some protocols make that kind of easy. Like a BACnet or a KNX makes that kind of easy. A CAN or a mod, it's not part of the protocol, right? And so in those cases, we do some fingerprinting where we look for what registers have what types of values and what shapes we can get out of it, and we try and apply that fingerprint to a known set of fingerprints that we have. And so the end goal is, once we get that data to the cloud, the metadata is matched against something that we call device profiles. And these device profiles are essentially representations of, for a Carrier Model 30 RUT chiller, here are the values that matter out of the BACnet digital inputs and outputs, and analog inputs and outputs, and here's how we need to map them into our ontology. Those device profiles are entirely built through automation, little more than I want to go into today. But we have about 30,000 of them at the moment, and those are individual sort of make, model, firmwares of devices. And then once it's in our cloud, we use a bunch of machine learning, a mix of natural language processing and correlation techniques to try to draw sort of the edges in the graph, to connect all the individual vertices, so that we can produce a model of how the devices are interacting, and whether that is an explicit interaction, something that we see out of the controller, for example, when the thermostat changes temperature, the VAV kicks on, or whatever it happens to be, versus an implicit relationship, which would be something like when the elevator door opens on the third floor, this occupancy sensor from the lighting system always triggers. There's no real relationship between those two, but they are geospatially related. And so over time, we can draw a correlation and say that they tend to have some interaction with each other.
Well, that starts to trigger the security privacy concerns. Maybe the elevator door opens, you get that proximity sensors. And there's a person walking. Oh, let's trigger the camera and see who the hell is walking around.
Yeah, that's right. Well, and just to be clear, so we don't do anything with video. today,
Okay.
but we do take metadata coming off of video streams. So for example, a company like Verkada that has cloud-based APIs, and I don't think I mentioned that before, but we are seeing an increasing number of cloud-first vendors going into these spaces. And so you take like a building that already had 10 protocols in it and 12 vendors, and now there's Verkada and VergeSense and Envoy and Density and on and on down the line. Right. But a vendor like Verkada that already does video analytics and produces metadata, the camera can report that it sees 3 people in the background at that given time.
Okay, but you're not pulling the video. You're just pulling, as
That's
you said,
right.
the metadata. So, floor 3, 2 o'clock, 3 people.
That's right. And then you may want to correlate that with like badge swipes, from OpenPath or HID or whatever you happen to be using. I saw 3 people move through this doorway, but only 2 badges were swiped. Maybe somebody's tailgating. I should go have a conversation with somebody.
So obviously, I'm finding this super interesting. My question for you is, who's your customer here? Who writes you a check?
It's a little bit of both. So we do have a platform fee that we charge to the building. We try to keep that as small as possible. It is a flat platform fee. So unlike most companies in this space, we don't care how many points you have, how many stories the building is, how many square feet. It's a flat platform fee.
All right.
And then on the developer side, the end goal of everything we're doing is APIs, right? So there is an API set. And we charge a metered API usage, same as any other cloud SaaS service would.
Okay, so your model's cloud SaaS plus platform fee. So you might have multiple platform fees paid in a given structure or factory, or as an example.
If there are multiple data producers in that, yes, that's correct.
Okay, so let's kind of shift to, we talked about buildings. I think buildings, there might be a smart city aspect to this as well, because multiple buildings make up a city, obviously. But let's look at factories. What's your play in the factory world? Is it basically the same thing? I can see I've got the fingerprint of all this equipment. These old 30-year-old compressors are compressing, and all the other stuff. Other stuff is whirring and whizzing.
Descriptive. Yeah.
Yeah, it's on the technical side. So, but what is it the same thing? So you go into a factory, there's a platform fee. You're going to try and sniff out all the different things that you can. So question number 1 is, what if you can't figure out what that thing is? Whatever it's a 40-year-old compressor compressing.
Yeah, figuring out what it is pretty easy. Figuring out what its purpose is inside of the environment is much more difficult. If you can take, for example, a temperature sensor. If I find a temperature sensor and I know the make and model of it, I know it's a temperature sensor. I know what fields I need to look at or what registers I need to look at. The harder part is that temperature sensor, sensing the heat of a robotic arm, or is it sensing the heat of an oven that's cooking whatever the food is that's moving down that factory line? It's really, really hard to figure out what's going on inside of there. So we do something that we call controller introspection, where if we can find a controller that we know how to speak to, we will actually ask the sort of environment owner for the credentials to that controller. And we will reach into the controller to pull out its programming. And we use that programming to try to figure out explicit purposes or explicit relationships of some of these pieces of equipment. And then this is also where some of the NLP comes in. So the point names, as these things were commissioned over the last 50 years, some human did sit down and put some thought into the name that they gave it. And so, if you see that FL3ZN1 TSTAT6, you can start to figure out, it's the 3rd floor, zone 1 thermostat, right? And but again, it was a human that created that. And so what we find is that there are both regional and sort of time period based differences on the naming schemes for different points. One system integrator that was going around LA in the 80s tended to use the same thing, but then by the 90s it was totally different. And so the NLP that we apply is really to try to figure out what the actual purpose of this device is, rather than just what the make and model of the device is.
So would you be working in the factory setting with PLCs, the logic controllers?
Yep. Yeah.
So
When,
that's an example of that. So you'll try
that's
and
right.
create almost a twin of the PLC.
Yeah.
I hate the digital twin term, but you used it for.
That's right. I try to avoid saying digital twins. I think
No,
after my time at Cisco, it was just so abused that I
I
try to
know.
never use it. But anyways, but yeah, that's right. So when we do the controller introspection, again, all the things that we're putting together are ways for us to automate what a human would have been doing in the environment. And so when I do a controller introspection, a human would have logged into the controller, looked at all the things that it was doing and how it was configured. And so we're essentially doing the same thing through automation.
It seems to me, just blanket statement without any data supporting it, it seems to me that many enterprises have tons of things that are in their environment that they don't know about. And it seems to me an interesting play would be to come in and, forgive the expression, map everything out.
Yeah.
Is that
Well,
one of your objectives? Is to kind of, be the mapping resource for all things within an enterprise?
yeah, look, I think if you just want enterprise asset management, that there are applications out there that are pretty good at just discovering what's inside of the environment. Our entire value is in that next step of, now we've discovered the thing. How do we get the operational data out of it and get that operational data mapped? That said, somebody could absolutely use our APIs to just create an inventory across their environment, because that's the first step of what we have to do.
It seems to me that's also a security play, because if you're the CIO, you probably don't know how many tens of thousands of devices are sucking up resources, quite frankly,
That's
or
right.
how many things are outside of my IT firewall, or whatever it is.
But I think also, as those networks are moving more towards zero trust, on the zero trust side, you need to have a feel for what your devices are doing in advance. You can't just go from an wide open network to zero trust. You need to do some work to figure out what's talking to what inside of that device.
So if you were picking sort of like the ideal sweet spot for you, what would it be? Obviously you must have sales or biz dev guys, and hey guys, go out and get me one of these. What is that?
That's right. Yeah. So today we focus on commercial real estate. We are moving into manufacturing and industrial as well, but the initial focus is commercial real estate. And what we are looking for is commercial real estate owners, operators, or tenants that have a pretty large portfolio of buildings that they own or operate or occupy, that are looking to use data from those for operational purposes. So it can be data science teams, finance teams, operations teams, but really trying to figure out, if I'm a very large tech company in 650 locations, how do I figure out how I'm using energy across these locations? How do I figure out how the space is being utilized? How occupant comfort is, and now also, safety and security. How do I make sure that people are safe when they return to the environment? And so our current focus is really on what we call first-party usage. The same one that's producing the data is also consuming the cleaned up, normalized data across their portfolio. But we will very quickly move into that vendor and second-party usage, and then eventually third-party as well.
So the guy that's using your stuff, the person that's looking at the screen, is likely the head of real estate operations within a distributed company, company that has offices in a bunch of cities and maybe even a bunch of countries. Yep. I'm thinking like Google or IBM or somebody that has sales offices and facilities around the world.
That's right.
What is the title of the person that would be kind of your primary user?
Yeah, so on that tenant side, right? So those examples that you gave would be tenants. Those tend to be a head of facilities, a head of building operations, a head of, it could even be a head of sort of a finance role that is looking to better understand the spend on that real estate as well. I think if you look on the owner operator side of the buildings, it tends to be more along the CXO side, CTO, CIO, Chief Digital Officer. And those roles are really looking at, if you take a Boston Properties, they're looking at a couple hundred buildings. You take a CBRE, they're operating or managing, several thousand buildings.
Right.
And for them to do that at scale really requires access to data, coming out of these buildings and in a normalized form where they can make use of it.
So they're typically looking at an interface that has kind of red, amber, green type charts that are looking at, multiple. Here's how your buildings are doing. Here's what here's some risks. Here's the red lights are.
Yep.
You've got a flood. You've got a fire. You've got your elevators are down in building 2. But
Well,
so I'm trying to generalize. But
sure,
what are they seeing? And I'm sure they're putting together their own dashboard.
That's right. Yeah, hopefully nothing that drastic that they're seeing, but yeah, they tend to refer to it as single pane of glass, right? That they want that single pane of glass where they can see everything across their portfolio. Some of the signals are predictive maintenance, FDD type signals. Some of them are energy optimization type signals. Hey, this building in this region is using way more energy than another building in the region. Let's figure out what's going on there. Some of them, are more really that example that I just gave is more of like an OEE type thing inside of a factory, right? How do I compare multiple lines? How do I look at the overall operations of this? Some of it is workforce ticketing. If you've got a leaky faucet, you've got a hot spot, a cold spot, some sort of fan that's not running, you need to dispatch somebody to go fix that. And today, those IWMS solutions are really manual, and they're looking for ways to optimize that.
So would you tie that, Shaun, into like a Salesforce, because or a ServiceNow, or because you're an API system, so it seems to me that you'd be offering them up some sort of web interface to get this stuff if that's what the client uses.
That's right. And so we do have integrations into Snowflake and Databricks and a few other things that they're likely already building operational dashboards on top of, finance and other operational dashboards on top of. I think the most interesting use case that we've seen so far, a customer is working on a screen that they can put in every elevator lobby. And that screen just shows the movement of people throughout that floor. So when you exit the elevator, you can see a heat map of where people have been and sort of how long it's been since they've been there. And so, this is sort of that return to work. I'd like to avoid big crowds inside of the office when I'm here. And so if I see a red hotspot, I just sort of stay away from the red hotspot until it gets a little lighter.
It's interesting. I used to know folks that did, the screen in the elevator, but that was an advertising play. It would serve up news headlines and then
captive audience.
Yeah, it was called Captivate Networks, I think, as a matter of fact. And they did have the ability to see who was in the elevator, and I believe they could sniff out the MAC address or some other signature off the phone to see exactly who keeps coming in at 9 and who keeps coming in, and who's who in the zoo, I guess.
Yeah, and so all the. Maybe the listeners don't know, but all the major wireless access point vendors now track mobile device movements. So Cisco calls it hyperlocation, Ruckus calls it Spot, I think, and Airwave. Aruba calls it Airwave. But they are passively tracking. The Cisco wireless access point has like 32 extra antennas that are just doing trilateration to all the mobile devices moving around the space and trying to figure out where they are. But it is hugely useful in retail and in a lot of other environments. Retail is largely using it for path to purchase. How long did somebody dwell outside before they came in? When they came in, where did they go? Where did they stop and do things? And you'll see retailers rearrange the store from time to time. It's oftentimes based on that path to purchase. They want to put the high margin items in that path. But now we're seeing it in office buildings too. I can see how many mobile devices are moving around my space, how many people are inside of the space, which versus a lighting occupancy sensor that just tells me occupied or vacant. It's a huge amount of information you can get out of that.
So it sounds like they'd be, you said in the elevator and maybe in the lobby, you'd want to present up how many people are in at work today and where are they, just from a, numbers of people and where are they located standpoint, as part of the return to work from COVID stuff.
Yeah, there's a lot of great use cases around that. Although I'd like to hope that the lifespan on those is fairly short. We don't need them for too much longer.
It's only been a little over a year, so who knows? But no, that's super interesting. So what's kind of the wildest use case that you guys kind of see? Just to throw one out there.
Yeah, I think some of those return to work use cases are really the most interesting right now. A lot of the use cases are just purely operational. I want to know when equipment fails. I want to know how much energy I'm using. I want to know, if people are tailgating, those sorts of things. I think the more interesting use cases over time will be when the municipalities around these buildings, the smart city examples, start to make use of data coming out of the building, right? If every building in the city has the same API, you can imagine that the city can now do things like, hey, when Salesforce Tower empties out at the end of the day, and there's 30,000 vehicles entering the road, maybe we change the timing of the lights, or we change the way that we get all those cars out of the area to reduce traffic. I think similarly, if there's going to be a protest or some sort of event in front of a building on a given day, having the building be aware of that sort of geopolitical or other type of environment around it means that the building can react and say, okay, there's going to likely be less people in the building today. I can use a little less energy trying to keep the space cool or keep the space lit up. And so I think that as we move from not just the siloed environments that are inside of the building today, there's lots of interesting stuff we can do just connecting the inside of the building. But as the building starts connecting to the outside world and the outside world starts reading from those buildings, we're going to find just a lot of very interesting use cases that hopefully make all of our lives a little bit better.
It's like almost a good place to leave it, but I think we're pretty much on our home stretch. But
sure.
In terms of what people should know about your company, so very quickly, you're venture capital funded.
Yeah, backed by Greycroft and Animo out of Miami, as well as Acceleprise and a handful of angels as well.
Okay, and you're based in the Bay Area,
Los Angeles.
Los Angeles.
Yeah, although we're sort of spread all over the world, as is the case with all the companies formed during COVID. So I think we're about 10 in the U.S. and 5 out of the U.S. right now.
And if you were reaching out for technical people, what kinds of people do you need, and what kinds of developers do you want, working with your toolkits?
Yeah. So on the customer side, the developers we're looking for is anybody that is in the data science, finance, operations world. Sure. Our API is GraphQL based, so fairly modern API. And as I mentioned before, you can take a look at brickschema.org to get a feel for what's available in the API. If you've built an integration into Twilio or Stripe or pretty much any other modern SaaS API company, I think you'll do just fine with our APIs. Over the next couple of months, we will be open sourcing a handful of sample applications that are built on top of our APIs, just to showcase what's possible and to really, I guess, get developers started on making use of those APIs as well.
Oh, this is perfect. So I think, we've gone a reasonable amount of time. Hopefully we haven't lost anybody. For me, this was super interesting. You have an interesting background. I like what your company's doing. It went from platforms to, hardware connected things and things on networks to now we have, essentially APIs that are going to run the world in a strange way. So I think, hopefully, I think that the challenges are understanding all of the plumbing and privacy issues that we've talked about, but I think you've got them well sorted out. But plumbing and privacy is, as unsexy as that is, those are important things. But Shaun, I do want to thank you. I want to thank you for your time and again for responding to essentially a cold call to have this chat.
Happy to do it.
Yeah. So this is again for those that made it through the whole thing. It's in support of the Connected Things conference that we run at the MIT Media Lab, May 17th, maybe in person in the fall. Shaun will be available if you want to hit him up. It's mapped.com, as you see in the upper right-hand corner of the screen. There it is. Yeah, you have to figure that out on the screen because it's not intuitive. But Shaun, thank you so much for your time. I really appreciate it.
Yeah, enjoyed the conversation.